Okay, so today we're going to be going through this paper 1, which was for the double science students, and that tested the topics of chemical tests, bonding, chemical maths, and crude oil and products from oil. Okay, so let's make a start. Okay, so as we go through this video, you can pause it to read the questions and then unpause it to hear me go through the answer. So this first question is all about the change of state from a solid to a gas. Now this is really, really unusual, but that is sublimation. Iodine is something that does this quite well, and you might have had a demonstration of that when you were in year 9. Describe the test for carbon dioxide gas. So this one, you've just got to learn, I'm afraid. Bubble into lime water and it turns cloudy. So you get a mark for talking about lime water and a mark for it going cloudy. You don't necessarily have to say bubble into, but it's good in terms of having our full sentence. So next question is all about carbon dioxide being a simple molecule, and why does it turn from a solid to a gas at a low temperature? So that's always to do with forces or bonding. And in this case, because we've got a simple covalent substance, it's all to do with forces. So if we think about carbon dioxide, it looks like this. You have got molecules of CO2 just floating around. It's a gas at room temperature. And between these molecules, you have intermolecular forces, forces between molecules. So when we are boiling it or subliming it or melting it, you are breaking the weak intermolecular forces. You are not breaking the covalent bonds. You're not splitting it into carbon and oxygen. You're just splitting apart the molecules. So to answer this question, we need to say something like it has weak intermolecular forces between its molecules, which require little energy to break. So one mark for talking about little energy and another mark for talking about weak intermolecular forces. Okay, we're going to move on to the next question, and the next question was all about chemical tests. So the first part was give the formula. Now, lots of people forgot that, didn't read that part, so they actually said lithium, which is correct here, but it wasn't the formula. So lithium, its symbol is Li, and it has a positive charge. Now, that's because lithium is in group 1, so it loses its outer electron to form a positive ion. So remember, electrons are negative, so if you're losing a negative electron, you are left with more protons in the nucleus, so overall the thing is positive. So name the cream precipitate that is formed here. Well, we know, if we learn all of our colours, that cream is an indication, after this test, that we have bromide ions. Okay, so we've got the indication there, but what is the precipitate? Well, the precipitate is what you see, that colour, and that is silver bromide. So if you did this test with chloride ions, it would be silver chloride. If you did it with iodide ions, it would be silver iodide. And then we have to identify the white solid. When they say the white solid, they mean the white solid from the question up here. So it's got lithium in it, it's got bromide ions, so we have to put that all together. Lithium, bromide. Now, because they didn't say here to, name it or write the formula, you can write the formula because they haven't specified which way they want you to present your answer. The next question is all about why the wire in a flame test should be clean when used in a flame test. So you want to say there are lots of different variations of what you could say here, but something like to prevent impurities interfering with the flame, to prevent impurities interfering with the flame would get you the mark, or with the results of the test, or something like other ions might interfere with the test, or other substances could alter the flame test. Something like that would be fine for your answer. Down at the bottom here, this was a nice, quite simple one from year 9, thinking about properties of metals. So what is the property of a metal useful here? Well, yes, metals do conduct electricity, but we don't need that when we're doing a flame test, so it can't be that. Yes, most of them are dense, but, again, that's not really relevant here. So it's going to be the high melting point and the fact that they're unreactive. So we don't want a metal wire that's going to react with the thing that we're trying to test, and we also don't want the metal wire to melt. So that's why we've picked those two bottom ones. Let's move on to question 3. So with question 3, determine, this is all about organic chemistry now, so we're looking at crude oil and products from oil, those topics. Determine the number of atoms in one molecule of methanol. So I've got 1, 2, 3, 4, 5, 6. Just got to count up those atoms there, there's 6. State why it is not a hydrocarbon. So again, nice, quite simple question there. They want you to be aware that hydrocarbons contain only hydrogen and carbon. So we could say it contains an atom of oxygen. Now, it would have also been okay if you literally just said it contains oxygen. That would be fine. Okay, so down here, they want state what is meant by the term covalent bond. So that's something that you really just need to make sure you learn because it comes up time and time again. So it is the electrostatic attraction between a shared pair of electrons and the bonding nuclei. So you really have to talk about a shared pair of electrons there, and you want to talk about that electrostatic attraction between the positive bonding nuclei and the negative electrons. So that's what electrostatic means here. It's that attraction between the positive and negative things within those atoms. Okay, so next question is a empirical formula question, which comes up very, very often again. So you really need to make sure you're okay with how to do this. So firstly, we need to know, well, what is empirical formula? Well, it's the simplest whole number ratio of atoms in a molecule. So, you might have a molecule, for example, you might have this thing, which is actually called benzene, up here, C6H6, and that's its molecular formula. That's actually how many atoms we've got. And if I asked you what is its empirical formula, I'd be looking for the simplest whole number ratio. So that would just be CH, because for every one carbon, we have one hydrogen. So that's what we're looking to do here, work out that ratio. So the way we do it is we pop the percentages up here. Now, you can sometimes see questions where these percentages are masses, and that is absolutely fine. You do the calculation in the exact same way, because we could just imagine if we had 100 grams of each of these, or of the whole thing, that 38.7 grams of it contains carbon, etc. So we're going to work out number of moles first. That's really important. If we work out the number of moles of each, assuming that we've got 38.7 grams, then we can work out the ratio. And I'm doing that by dividing them by their relative atomic masses. Okay, so remember, moles is mass over mR, or here, because we've got elements, it's relative atomic masses. So we're going to do that calculation now. And I've got my values. And now to work out what the actual ratio is of each of these, I need to divide by the smallest number, which is 3.225. So these ones are nice and easy. They come out at 1. But when I do this calculation for this one, it comes out at 3, about 3. So what is really, really crucial is that you do actually write your final empirical formula, which is this down here. So you do get a mark for actually writing that. And then your second mark is for trying to work out the ratio, and your first mark was for working out those moles. Now, down here again, typical type of question you could get. The relative molecular mass of the compound is 62. Determine the molecular formula. So, the way I would do this is that I work out, well, what is the mass of the relative molecular mass of this if this was just the molecule? So that is 12 plus 3 times 1, because we've got 3 hydrogens and an oxygen. And that comes to 31. So I can immediately see that 31 goes into 62 2 times. Okay, and then I just times the whole thing up by 2. So I'm just making a note here for the examiner that I know that it's that times 2. So it's C2H6O2. So you get 1 mark, so I just moved that up. You get 1 mark here for doing getting your final answer, and another mark for some kind of calculation showing how you arrived at your answer. Okay, the next question was all about an acid and a base reaction in the context of chemical maths. So complete the equation by giving state symbols. Now zinc is a metal, so metals are always solid. Acids are always dissolved in water, so it's aqueous. And zinc sulfate, here is testing whether you know the solubilities of the salts here. That is also aqueous, and hydrogen is a gas. Okay, so zinc sulfate, because it dissolves in water, it's a soluble salt. That's why you've got the aqueous symbol there. So the student obtains a pure dry sample of zinc sulfate crystals. Calculate their relative molecular mass. So to do this, you just literally add up the atomic masses from your periodic table. So I can see that zinc here is, where is zinc? It's up here. So it's 65. I've got one of those. Plus I've got a sulfur, which is 32. And I've got 4 oxygen, 16 times 4. Now what's interesting is this little dot. That dot means water of crystallization. So that means that for every 1 zinc sulfate crystal, we've got 7 water molecules attached. And I know that H2O has a relative formula mass of 18, because an oxygen atom is 16 and hydrogen is 1, and there's 2 of them. So instead of, I'm just going to literally times 18 by 7, because I know that 1 water is 18, molar mass is 18, and we times that by 7. And when I do that calculation, I come out with 287. So you get 1 mark for your working, as always, and 1 mark for your final answer. So next question, your student uses 0.0200 moles of dilute sulfuric acid. Show that the maximum mass that they can make is about 6 grams. So firstly, we need to use our molar ratio. So at the top, we've got an equation. So sulfuric acid to zinc sulfate crystals, it's a 1-to-1 ratio. So the number of moles of zinc sulfate equals 0.0200 moles. Okay. The maximum mass of zinc sulfate crystals, and I like to lay my working out like this so I know exactly what I'm doing. So remember, number of moles is mass over mR. So mass is number of moles times mR. So 0.0200 times the mR that we used up here. And that comes to 5.74 grams. So you get a mark here for this calculation and then a mark for your final answer. Now, percentage yield often comes up. So the student actually only gets 4.28 grams of zinc sulfate crystals. So percentage yield is the actual yield over the theoretical times 100. So imagine you were doing a test and I said, what was your percentage mark on that? You would do your actual mark divided by theoretically the maximum mark you could get and times that by 100. So I actually got 4.28 grams, but I expected I was going to get 5.74. And then if I do my calculation correct, it should come to 74.6. So these two marks are all in one because you could do the times 100 in a second step. So I've done it in one step, so those two marks go for that step. Okay, so we're nearly there now. We're on the last question of this paper. Crude oil is a mixture of hydrocarbons. Name the process used to separate it. Well, that is fractional distillation. Give a use of the kerosene fraction. So this is just something you have to learn. So aircraft, fuel. Some of you are still not using the word fuel. You're saying it's used in aircrafts. You have to be really specific. It's a fuel. You could have even said cooking fuel there. There's a number of different things you could say. Next question is about this alkane. Now it tells you it's an alkane, so that's nice and easy. We know it ends in ane, and it's got 1, 2, 3, 4 carbon atoms, and so we know it's butane. So most elephants prefer bananas. Remember, if something's got 1 carbon atom, it starts with meth, 2 eth, 3 prop, but 4. Okay. And calculate the relative molecular mass of this alkane. So I can already see that I've got 4 carbons, so 4 times 12, because the atomic mass of carbon is 12, plus I've got 3, 4, 5, 6, 7, 10 hydrogens. I add those together and I get 58, and that's my relative molecular mass. Determine the molecular formula of this alkane at the bottom here. So this alkane is in the gasoline fraction. So we've got C, 1, 2, 3, 4, 5, 6, 7. And you can do this two ways. You can just count up the hydrogens, or if you remember the general formula, you know that you've got double plus 2. So 14 plus 2 gives us 16. And I'm just going to write down my general formula down here because it's asking us for that. So it's really important that you remember these general formulae because they can really help you out when you're working out molecular formula. Last little few questions is all about cracking. So again, cracking is something that comes up an awful lot. The catalyst used, well, you could say a number of things. Alumina, silica. We would also accept zeolite. We would accept aluminium oxide, silicon dioxide, because those are just alternative names for these. So hopefully you said one of those. So next question, this again comes up so often. Explain why it is necessary to convert long chain alkanes into shorter chain ones. So you want to talk about there being a greater demand. There is a greater demand for short chain alkanes compared to long chain ones. And then something about you could either talk about there being more long chain alkanes than are needed, or there's too many long chain alkanes, or something like, and I'm going to put this here, not enough short chain alkanes to meet demand. Okay, because what we want is we want lots of short chain alkanes, but after fractional distillation we get lots of the long ones, so then we need to crack them to turn them into the shorter chain ones, which are much more useful in fuels, as fuels. Next question is a cracking calculation. So, not calculation, an equation which often comes up. So we know that long chain alkanes get cracked into alkanes and alkenes that are short chain. So it says two different alkenes. So you've got, I'm going to just work out how many carbons I've got left over. I've got 6 carbons left over here, and I've got 12 left over. So we're playing with 6 carbons and 12 hydrogens. So immediately, if I put the first alkene down, C2H4, that's ethene, then I just count up the rest. So I'm left with 4 carbons and 8 hydrogens. Now, how did I know that they had those formulae? Well, I knew that because I learnt the general formula of the alkenes is CnH2n. That means there's double the number of hydrogens to carbons. So if I've got 2 carbons here, I've got to have 4 hydrogens, and the same here. Well done. Please do watch this video again if you've not caught anything, and also do please feel to come and see any of your chemistry teachers if you need a hand further. Thank you.